Hi, now we continue 8.4 diagnostics. So now the residual plots. So we use a different data set. So this is the Galapagos Islands data, and this is the number of species, and the sample unit is islands. So each island have the number of species and also some geographic information, such as the total area and the highest elevation and the distance to nearest islands and the distance to the Santa Cruz, that is some big city in the Galapagos Island, and also this is the adjacent, so the area of adjacent island. So if the one island is nearby a large island, maybe they have more species. Yeah, and the endemic variable. So this is kind of a subset of the species. So we exclude this variable and we fit this species on other variables. And the y is count. So we use the Poisson regression. Yeah, so we fit the species on the other observations, the other variables, and excluding the endemics and Poisson regression. Then we can make the residual plot. We have the slight difference in these 4 residual plots. So this is usual residual, but this is the residual response. So the no option. So this is the deviance residual and the response. So this means the usual, the residual, the y hat minus y minus mu hat. And predicted value, there are also 2 types. The one is the usual predicted value. So this is in the scale of mu, or I would say mu hat or estimated value. And the other 2 has the link. So this is the scale of eta. Okay, so we can see the graph. So at first, the residuals have 2 types. So residual, so this is the deviance residual, and this is deviance residual, and this is the usual residual. So that is y minus mu hat, and this is y minus mu hat. Okay, and the predicted value. So first one, the response. So this is the scale of mu, and this is eta. Eta is the g of mu. So g of mu is basically linear function of beta. So in this case, actually the deviance residual is important. So y minus mu hat is this the size of the residual that depends on the level of mu hat. So actually you can see some increasing trend like this. So it's not the variance of the residuals are not the uniform, but this is okay because the deviance residual is more important quantity. So y minus mu hat, since we haven't divided this by the standard error of y minus mu hat, it's natural that the y minus mu hat is not IID. So deviance residual is more important. And to compare with this, usually the eta is better in terms of distribution. So the eta is the g of mu. So in this case, the log of mu, and more uniformly distributed from left to right. And here we have nothing wrong, but the mu is more skewed. So only few observations on the right-hand side. So probably this figure is what we have to generate. So this is the good residual plot, so important plot. So this residual, that we should not have any pattern. So the predicted value and the residual, that we shouldn't have the heteroscedasticity. That means the different variance over different value of eta. And we shouldn't have any pattern such as curvature. So in this case, we have almost entirely random. So the assumption on the error terms are satisfied.